Okay, second stream, hopefully this time with audio. And I explained all this before, but of course my microphone wasn't actually working. Uh, Basically, this is a 3D printer I'm working on. Go over the features later. But basically the idea is that this should be just a no compromises, create pretty much whatever you can to design, relatively fast, relatively reliable printer that does not have a name on it that makes it cost 10 times too much and use DRM to filament. Not naming any names there. Uh, so yeah, this is going to be open source, and if I could get some community involvement, that would be great. If not, well, I'll just make it by myself and open source it anyway. Uh, so quick basic thing. This has 6 extruders, and inside we have a delta arrangement with 6 hot ends. So we can have 6 different materials, or, well, for instance, you might want 5 different colors of ABS plus a support material, or you may want a part that's ABS and Ultim and nylon and uh, whatever else random thing you find and support material, and you're covered for some pretty complex designs. Uh, and with even with just the color options, it allows you to design things and make them, and then not have to paint features on. You can print them out done, basically. Uh, so a lot of design has already happened here. Uh, Next step that I am looking at, so we have the carriage with the hot ends, and those are being fed by this extruder group, which the motors are inside. And I need to add some vents or something to this, but that can wait. Uh, so those feed from the filament out detectors, which just have filament rolling through. Actually, I just realized this one is mounted upside down, which means they all are. So have to adjust that. And it's feeding off these spools, but as you can see, I really don't have anything for the spools yet. I've got an idea, and so that will be what I'm going to do today. But first, I have to put these on at least remotely where I want them, and that will allow me to figure out where I want these and so on. So just want this to be parallel and the other parallel, and then all the others should be facing the same way. Looks good. And since I hid some bits, I'm just gonna show them again. Alright, so this has 3 screws to attach it. I could probably get it down to 2 if necessary. So I'm gonna hide this, and I think the best place to attach this would be to put those screws right into there, tap this aluminum beam, and yeah, that'll work. Just have to see if you could probably get all 3 in there, but this is relatively low. Yeah, I might as well get all 3 in there, I guess. So start a sketch over here, and I'm just gonna convert this whole face, and that way I can get the center of it. Okay, so that dot is the very center. And if I go over here and do a convert entities on the inner loops, then we have that pattern stored inside of this part. So we can just open this part, and now we can work in that sketch without everything else being in the way. So I am basically just going to kind of copy this pattern Okay, so made a pattern that I can copy out of that, and I can just do a copy. So parallel equal, parallel equal. Just gonna fix one point so I know when I'm done. It's gonna be equals. What are these three? So we're gonna want those to be smaller, but we're gonna make them all equal. And for tapped holes, I just make them at the actual tap drill diameter. And I want those to be equal as well. So that's fully defined. So if I remove that, okay, now we can kind of center that. Make a rectangle around it to figure out what I'm actually using here. Tangent, just make some tangent mates. Okay, so that rectangle is the overall outer size, which means that if I do a midpoint right there, okay, I just need to hide the rectangle then. For construction, need to hide this, and need to hide that. So at that point, all I should have left is these holes. I still have. Let me just hide or turn everything to construction and select just what I want. Okay, now I should be able to do a cut. Yeah, 10 millimeters, that's clears. I'm gonna break the external references because they were basically just to give me that pattern. Okay, and now I've got that pattern on that beam. Now I've got two other sides, and they do have different part number beams because this, while it is roughly the same all around, there are minor differences. Just gonna completely hide the triple one because that was kind of a silly idea. It didn't really pan out because of trying to line up the filament in an efficient way. It just didn't work, especially if I want to have an enclosure around it to keep it relatively dry. Okay, so I have this bar. If I just copy and paste it over here, all right, and looks like it's got the three holes from that last filament out detector with the triple one. So we'll just cover those up. And they're gone. I know that's very sloppy. I don't care. It's my project, and if I'm ready to actually release this stuff, I'll go through and make it all good. But I find that a lot of times in design, you get so many changes and so many parts that you end up modifying over and over again, and they end up getting huge. So it's just better to kind of work with what you got. Don't really go back and fix things, just make it look right and the right size and dimensions and everything. And then when you're satisfied with it and it's all set, then it's time to fix it and make it look good. Alright, so this one also has the same issue. Just gonna fill in these three holes. Okay, that's good. Then show this, and I'm gonna copy this one. And just made it the same way I did the previous ones. These are all the same length. And I want this to be in the center of all of them. So I can do that pretty easily. So even though I'm working this part, I can still sketch on this plane. It doesn't really matter at all. I'm just going to cut up to next. And that should cut the pattern through. Yes, it did, but not up to that one. Okay, and then I just need to edit this one. And I'm going to do the same exact thing. To next, sounds good. And then I'm going to break those references because it's just a pattern. And I like breaking references anyway because SolidWorks, it can get a bit choppy when you've got external references, and it really slows things down as well. Alright, so we can get rid of these three because they were just there to transfer the holes. So now I've got the holes there, and holes there. All the same pattern. Gonna show everything again. And I'm just gonna get rid of these so that they stop popping in because I am not going to use them. I'll just suppress them just in case I decide to change my mind later. At least when I show everything, they won't pop in again. Alright, so now I need to do add that same pattern to here. And how I'm going to do that is, actually, hide this first. Then create a sketch and go back to that, get those holes. Just going to convert them and do an extruded cut through all. And that's set. Over here, I'm going to do this panel as well. Again, I've got holes to patch, so I'll just do those real quick. So much easier than removing drill holes in the real world. And again, we'll just copy this sketch out of the cut. And through all. Okay, one more to go. Alright, so that's patched. Then we just need to copy the sketch one more time. Okay, gonna list all external references, break all. Okay, and just because that was a lot of external references, breaking and all that, I do a Control Q to do a full rebuild, and then I save. And save. Alright, so now I can start attaching these. And that's fully defined. Good deal. Just kind of pull these off the edge so I can actually get at something to mate. And there we go. And one more. Okay. Now, one minor issue I just realized is that those holes we just made are at tap drill size, which is fine for the side, the parts that are actually supposed to be tap drilled. Actually, we don't want to hide those. Edit. Okay. So, just gonna hide all the filament detectors. Okay. So then I can go in and change this to be 3mm holes here. So these are just through holes. That way I'm not trying to thread into a panel. And yes, this will break some mates, but yeah, we can make them again. And sure, I could just modify the sketch, but this works too. And yeah, when this is all ready, it's just going to be step files anyway, so it doesn't matter how they got there as long as they're right geometrically. And one last set to expand. Okay, and let's show these again. Okay, there's the mate error that I was expecting. Just delete those three. And we have to redo those mates again. Seems like an annoyance in a way, but at the same time, by doing this as you go, you save yourself a lot of coming back later and going, oh yeah, those holes didn't quite line up. Now I've got to redo that panel that I've already made a drawing for. Okay. So we have our 3 filament out detectors. They're in place. And go back to showing everything. And do a force regen and a save again. In SolidWorks, in any CAD software, you should save a lot. In SolidWorks, you should save an absurd amount. Not to bash SolidWorks or anything, just you really should. Okay, so next question is how to support these filaments or these filament spools. Some machines support here, and some machines support at the bottom. And each has their advantages and disadvantages. In this one's case, I am going for middle support just because it's a little bit more secure. Basically, if we have a middle support coming out through here, and we have some kind of clip-on, screw-on, whatever device at the end that keeps it from coming off, and you can move this around the office. You could even ship it with filament. Not that I'd recommend that. Whereas if you've got supports at the bottom, it's possible that might actually pull off if you upgrade your stepper motors. So uh, I'm going to go with the center support on that. Also, these eventually are going to have a shell around them that's sealed. And because of that, I want to minimize their space that they're using and also move it up so that basically it'll tilt down from there and be. I'm gonna have to modify this cover to be a little bit more square so that it can just kind of fit around that. But yeah, okay. So these are basically some of the biggest filament spools that are out there. So I'm not too concerned with someone using something bigger, because I mean these are already relatively large 5 kilogram spools. So, but I am gonna, just in case they do use these and things are a little bit off here and there, I'm gonna put say 10 millimeters between them, which isn't much. So that'll work, or it should anyway. We'll see. And I am also going to make these. Ooh, is it this one? Okay. Make these coincident, and then I can rotate just a little bit. And if I make that parallel, okay, so now we can at least sort of get an idea of where everything is. Now, this panel isn't going to be strong enough to support the two 5 kilogram spools. But if we hide it, and I already have this cross brace behind there, and it looks like we're just about perfectly on there. I mean, yeah, that would be acceptable, right? Okay, well that works actually a little bit more wonderfully than I was expecting, so that's great. So I'm just gonna make a sketch inside the assembly context, and yeah, it warns me, of course, because they're not useful for making features, but they are useful for positioning things and then making features based on that. So if I'm just going to try to make something that will automatically center all of this. So I don't want to actually use any more dimensions than the ones I already made. Everything else can just be driven off of everything else. All right. And equal. All right, so those points are the center of these. I shouldn't have Control-Aid. That was a mistake. But okay, it didn't crash. Wonderful. All right, so yeah, I'm gonna exit this sketch, and I'm gonna edit this part. And I think an M5 should be more than enough for this. So actually, was it M5 by 1? I always forget those. I'll just pull in a screw to find it. Yeah, make it a button head. So that is a 4.2. All right. 4.2. And same thing over here. Even though it's a different part. And I just want to go up to next. Select. All right, so there is a hole there now. Okay, beautiful. And I forget I have a hole here on my own. Nope, I do not. Actually, see, this is 22. This is 22. Are these all 22s? They are all 22s, so I'm going to have to change that as well. So I'm going to do a save as on this. And see, 30, 41. And save as a copy. And then I'm going to delete that last feature I just made because I don't want it on these. So I'm going to select these two that I don't want to change and give the new ones not all instances, just want those two, and check, and it reattaches all the mates because of the same part, same feature IDs and everything. And then we need to wonder why this one is wrong. I might have it rotated 180 degrees or something. Before I fix that, I'm going to break this link because rotating that around is going to mess with that sketch. And then I don't need the sketch anymore. And I can move these down. Oh, then I have to figure out why. I'll basically just suppress all these mates, and yeah, that probably work. I'll just open the assembly that it's actually in, save some trouble. So I'm guessing that on the other side, yeah, there's the hole. So I just need to suppress all the mates on this part, and then I can rotate it around so that it's correct. And then I have to recreate the mates, but that's okay. And just checking on the stream real quick. Alright, looks like no one's watching. Wonderful. Okay, that's fully defined down here. So I'm going to show everything. And I'm going to edit this. Now I want to see something that's below that, so I could just hide the body. And I want those two, convert those up. And I want to show the body again. And then we need to make two 5mm holes in the same location. Just if anyone's ever wondered why something has some really weird dimensions for it, well, it's because of, most likely because someone's using a method like this, which just gets you the ideal dimensions, not necessarily something that's going to be nice and round. Do an extrude cut through all. So that's 8. That's not the one I was looking for though. That one is what I'm looking for. That's 5, good. And that's 5, that's 4.2, great. Let's break all references. And I'll show with dependents also. And save it. Okay. And we can show everything in here again. Alright, so now I need something in the long bolt or similar category. So I've got an M5 here, and those pretty much top out at 100. Let's see what else. And these are the hardware I've got here is stuff I modeled up based on what's reasonably available and reasonably affordable. So there's a lot in here, but some of the really large, long sizes, oddball stuff is not, because it's not the kind of thing you can just go and find wherever. All right, so that's pretty much close to the same. Let's try a socket cap. Try an 8. And how big does this go? That goes up to 240. And it's in black, so see how 240 looks if it regenerates. Yeah, I'd say 240 is probably long enough. Okay, so we don't need these. And SolidWorks is back. And we need to adjust these holes. So this last sketch, I made this 5. I need it to be 8. Okay, yes. And then in this part, and let's make this, what's 8 by 1.25? I believe so. Okay, yeah, I got that. Alright, so if we save, save. Saving can take a while. Alright, and this will probably not be the ending length, but we can start from it. And just drag it out. Okay, so we need some sort of, well, do we? And I suppose we could get away with just dragging it on the bolt, but it seems a little bit less than ideal. Let's see what kind of bearings are common and from someone I like and relatively affordable. So this will be an axial bearing, and yeah, might as well just go with that. I guess that's what I've got here. It's at least a good starting point. So 18 by 16, 18 by 22, or 8. Alright, so 8 by 16 by 5. How big is that? And I always like to do a regen after putting in a family table part. Okay, so that is 16. Alright, so at least in that reel, it's plenty of room, because we've got 16 versus 31. So, yeah, that'll do. Let's mate that up to here. And just to be thorough, we'll put one of these at each end. Okay. And let's see. Guess we're gonna need some kind of a sleeve that the filament could ride on. So make a new part for that. And let's see. So we want kind of a back side to keep from going in and rubbing against this panel here. And we want it to be large enough to go around the bearing. So can start just convert this, and this part is, at least in prototype, going to be 3D printed. I want, if I can, to get about 6 millimeters. So how big is that? That's 28. I have seen spools smaller than that, but they're pretty rare. I believe. Let me try another spool that I have here. Hmm. Let's see where is this saved? Saved as 3D printer filament. But nothing else in there is. I could have sworn I had a 1 kilogram somewhere. Or a few of them anyway. But yeah, I'm happy enough with this. We can always modify this later if necessary. Well, yep. Saying that, I'm just going to drop down to 5 right away. Which that gets our outer diameter to 26. It's just a hair over an inch also. So yeah, it should be good. Okay. So this is currently, let's see, is this currently coincident? It is. All right. Well, that's handy. Go back to edit the sketch, and we want up to there, basically. That'll work for now. You can always extend it later. And then I want a backside thing. So 100 millimeters. Nice round number. It's pretty unlikely you're going to find a spool filament with something larger than 100 millimeters. And try 6. That works. All right. So that needs to be 6 more. All right. And this is 5 millimeters. So if I open just this part on its own, I will sketch here, copy that, and then I'm going to just make it a little bit bigger than the shaft. And I want to offset this by 6 millimeters the other way, and there. And then I want to offset by 6 millimeters. And that way it makes the tube a little bit more solid and gives the bearing something to rest against. Alright, and then we can break extra outside links because I'm going to start moving this around. Which also means I need to float this. And okay, so I will mate to that and put in the bearings. And there we go. So then I need another spacer right there. Oh, did I make out those offset 6? I sure did, didn't I? I will change those. 5 and 5. Okay, that looks better. Now I need something here. And just make a new part there. And come on, okay. So actually, could I just use a washer? I could just use a washer. I don't need to design a new part for this. And let's see what we've got here. So let's see what that looks like. So I want to keep it under 13.3. 13. It would scrape a little bit, but I know that the actual part will be a little bit filleted. This will be a little bit filleted. So I think that will just barely work. Beautiful. And just because these can potentially be just a little bit wobbly, I'm going to double that up. Let's see, this one is 0.8 millimeters, so 2 of them, 1.6. That should be enough. Okay, so now we can mate that to the surface it's just going to be against. Wonderful. And I'm just going to make another copy of this one in case I need to use those as they are for some reason. That's not what I wanted to do. It's okay. There we go. And meet that there. Okay. So that looks alright. We need to have something to attach to. And how would we do that? First thing first, this is just going to be right against there. Just tightened up right against that bearing face. It should be fine. And then this needs to come out, or it needs to be more. So I'm going to sketch there. I'm going to convert the inside, convert the outside, and I'm going to extend that out by let's see, I want 6 and 6, so let's go with just expand that out by 13. And then I'm just going to open that part. Change this so it's not merging it, just so I've got a handy little line to work with here. And yeah, hide this for the moment. And I just want to have like a little groove that I can use to mount something in. If I can't really make it, if I make it any bigger than the rest of the shaft, I might as well make the rest of the shaft bigger. So it has to be going the other way. And 1 millimeter. Yeah, we should be okay there, but then this has to be, I have to bump that back up to 6. That's fine. Alright, edit this sketch again. Edit it. And convert it. And then I want to show everything. I do a cut that is 6. I'm gonna make it 6.5. Okay, then I can combine those. Alright, so now I can just make some kind of clip thing that slips over that. I want to make that as a separate part, just so I don't have to split it off later. Okay. So this can rotate, but other than that, it can't really get out of there. Actually, come to think of it, I could have several of these lined up along the way with clips that would go in. That'd be interesting. If the clip could be laser cut, just use some cheap ABS, just design a little flat panel, and then you go a little bit thinner with the graduations. So still want, say, 12 at the end. And then just get rid of the combine, get rid of the cut. And so, let's see. If I offset a plane by, say, still want 6 as the final one. And just copy that. Cut, and so that's standard 1/4 inch, which I'm in the States, so that's what's available, or 1/8 inch, sorry. And I'm going to put in another 0.1 for filament or printer inaccuracy, and another 0.1 for not swearing while you're putting it on. And we got that. Okay. So I'm gonna rename this first as okay. I'm gonna hide this plane because I don't need it anymore. I'm just gonna hide that as well for the time being. And I'm gonna combine these. Okay, so put an axis in there and put a plane. Oh, not that one. Try that one. You're happy about that? Good. Okay. So then if I do an intersection curve, that'll copy all my lines, and then I can just hide the body. And I don't need any of that side. Good deal. So now I can just kind of create a pattern of this, which we'd want to go like that. And so, yeah, just those. We want a linear pattern along. I don't have a solid feature. For some reason, linear sketch pattern only works along solid features and not sketch entities, which is kind of annoying. Alright, so what if I just, on this plane, make that? And that's collinear, that's parallel and equal, that's perpendicular, and yeah, just make sure it's fully constrained. Good enough. I don't want to merge it, just a reference for my sketch. Okay, so I can do linear sketch pattern and along that way, but I want it to go the other way, and I want its spacing to be, oh geez, I don't even know, but we'll make 10 of them, 12, 13, yeah, if you got smaller filament than that, I'm sorry. Alright, and then between them, I want 4? 3? 3 work. Okay, so maybe I should have made that more, but I can say 20. Okay, so that should do there. I'm just gonna make those for construction, make those for construction, it's already for construction, and that's already cut out. Might as well leave it. So, alright, then I can do a revolve cut around this axis with these, no, don't want a thin feature. Yeah, I must have forgotten to make something for construction, but that's fine. I'll just pick all these manually, I guess. Okay, that works. And then I don't need this body anymore. Good deal. Do a control Q. Anytime I delete a body, I do a control Q because it freaks out sometimes. Alright, so there's our shaft that you can drop ABS locking plates onto. And I like ABS because it's kind of flexy, but also kind of strong, and most importantly, cheap. If you look at some of the other materials in here, that's clearly not the most important thing to me, but it is nice when you get it. Okay, so I'm going to create a new part, and it's going to be a little clip, and it's going to go right here. So I'm going to convert that, and make those concentric, and yeah, it's ABS, it's cheap, make it 100 millimeters. But we don't want a complete thing. We don't want a complete circle. We want a partial circle, but we can work with that. So if I make this a cut, I don't know what horizontal is. Alright, we'll call that horizontal. It's good enough. Alright, so I want to go a little bit past. I want to be bending out maybe 10 degrees. They're about, okay, so this is perpendicular, so that's a straight. And if I go like that and like that, I get those parallel. And then I measure this, or I set this to be 10 degrees. 10 degrees isn't much gripping. Let's try 15. 15 is a nice solid grip. Okay. So, I want this, and this, and this. Alright, and then I want basically a straight cut down to there. And perpendicular. Okay, so now if we make this ring, okay, it looks all right. Do I want to go just a little bit more? Yeah, I feel like that'll work, and if it won't, well, we can always go more later. It's not a big deal. Do I want to fill it on that edge? No. It may fill it itself over time, but no, I don't need to fill it on that edge at all. Okay, we do want fillets down here though. Pretty big fillets. 20? Too big. 15? 15 works, I think. Alright, and now I need some kind of get my finger in there so I can get the stupid thing off device. Which can just be a slot, I guess. Ooh, I can use a curve slot. Alright, not often I get to use one of those. And if I go from there to there, and there to there, and I want those to be collinear and equal, I want to be coincident with that, and I want it to be parallel with that, and it's fully defined. Okay, hide, return those to construction. I suppose I want 5-ish millimeters. 6 millimeters, 8 millimeters, and then so that's a 20 millimeter opening. That's a good size opening to stick your fingers in. And how wide should it be? Probably not that wide. Let's see. That can work. Set this to ABS. Looking good. It's nothing in there. And let's save it to an external file as well. That'll work. Alright, so if I go back to here and close that, and we can close the crossbar, and we can close the crossbar. Just like to keep those things closed, save windows. And okay, so I don't have any external refs. Good. And I'm gonna float this. So right, how thick did I make that? I made that 10 millimeters, so we want this to be, just to be clear, I'm not a big fan of using inches, but I'm in the United States and getting 3 millimeter material is tough. When you do get 3 millimeter material, or when someone's selling it as 3 millimeter, a lot of times it's actually 3.175 because that's quarter inch. And interestingly, from China, I've gotten the opposite, although there's never any way to be sure that the next shipment will be the same as the last. But I've had stuff that was sold as 3 millimeters, and I got it from China, and it was 3.175, which is eighth inch, which in theory, in theory, China is on the metric system, but I guess they make a lot for the United States too. So, all right. So this clip is good, but I just, yeah, where the planes are, that's no good. So I can rectify that pretty easily. Make an axis, and then where's Z? Z is far away. Okay, and so I want this to be with the axis, and I want this to be with the Z. Okay, and then I want, where's Y? Let's see. Yeah, I'd want X to be parallel with that. Okay, so now if I go normal 2, it's actually looks correct. Do a Control Q, I save it, and when I go back in the 3D printer, it'll be who knows where. But hey, what do you know? It stayed. Oh, yeah, it stayed because of the mate. Great, awesome. And then we'll do a parallel to there just to make it look nice. Okay, so I feel like that's a decent enough system. So that will just rotate along with the whole filament spool holder deal. Uh, yeah, I'm happy. I'm pretty happy with that actually. You still have an axis showing? No, you don't. Something else does. Oh, we'll sort that out soon enough. All right, so just like that, we've got a filament setup or a filament spool holder. So get that. Two washers. I should probably look and see about that screw. So I'm guessing that it's far too long. Yeah, it's going clear out of the other side. Let's see what a 200 looks like. It's processing. Just hide everything that's in my way. I can bring it all back later. And hide all that. And that. Lots of stuff in my way. Okay. So that looks pretty good. It's that 180 millimeter. It's black oxide. It threads in there. Do I want it to thread all the way through? I mean, it's got a lot on it. And it is high up, so it's not a big deal if it threads all the way through, but then I have to do it on all of them. And I don't know if I want to do that. It's pretty far in, so it's not gonna, I can't put a weld nut in there. Can't really put a nut in there at all. How far in is that? Let's measure from there to there. So 145 millimeters. Yeah, you don't want to stick a wrench in there and try, and you probably could, but just barely, and yeah, that doesn't look like fun at all. But at the same time, I've only got 3 millimeters of thread for an 8 millimeter screw. So yeah, let's go back to it. See what a 200 looks like. Probably still not enough. Oh, there's a problem too. Yeah, so these are only partially threaded, obviously, at this length. So, yeah, these are all 28 millimeter thread. Right. So it'll be 180. And 150 millimeters. I know you can get a wrench that long and it's not ideal, but not sure really how else to address that. So if I get a nut, and I might as well get a good one that'll spread the load well. That's kind of frustrating, but yeah, I'm not sure what else to do with that. On a serrated 8 millimeters, I might as well get stainless. And yeah, okay. Yeah, that's why I always regen after I insert a library part. That hole needs to be bigger. It's not going to tap that anymore, which is a plus in that sense at least. There's the hole. Okay. All right. So where's that? Probably just hiding behind this, right? Okay. And mate to that. I don't like mating. I probably should have made it to the shaft, but whatever. Okay. So, oh, quick little thing here. For my thread standards, I model this at tap drill diameter and this at nominal diameter, and this whole end section is 3 threads long, which the last 3 threads I find are not ideal threads. So I like to get past those, unless it's a blind hole, obviously. But when I can, I like to get past those. So if I go to 200 millimeters, am I going to be into the next panel over? No, I'm not quite into that next panel over. So that's an option. But what about? Yeah, I'd like I like it out there. If anything, I might bring the screw out a little bit. No. 4 millimeters? Nah, that's fine where it is. And yeah, it's going farther in than necessary. Oh, yeah, that's a problem. So, did it measure? I don't think it measured. 4.72, or normal distance, 2.5. So if I bring that up 4, I should have clean threads, in theory. let's see here. Let's start by bringing this up by, oh, I don't know, 2. That way that bolt's still recessed a little bit. And I could make this a little bit thicker, but it's already 6 millimeters thick. Yeah, I could go to 8. And then I can bring that out 2 more as well. And yeah, I know I'll have broken mates when I come back, but I can fix them easy enough. Okay. Then I'm gonna hide that axis. And yep, that's fine. Funny thing is, it's not actually saving the part when you do that, but it suppresses another dialogue that's, so whatever. And can I see it? I can just barely see it. Good. Alright, and I need to make a new mate for that because that old face is no longer there. It's buried. Good, good. And if I just go down to my mates, got a coincident and coincident. 2. Alright, good enough. Good enough. And so I should have the nut there. Alright, good deal. So I'm going to start putting everything in this folder. Filament, I want the 2 washers. I've got the part that I've just named parts so far. I've got the 2 bearings, and I've got my screw. I'm going to add all those to a folder. And then I'm just going to hide the folder. And just to confirm that, yes, everything that I want in that group is there. So I have this, or I have this part 1. I don't like it being called that. And no external references. I'm going to make this out of black ABS. And then I'm going to save it. Filament spool shaft. That'll work. And go back there. Alright, so that is now set, and I'm going to make a subassembly out of these. And that way I can just edit that without everything else kind of getting in the way and slowing things down and all that. I'll just start by fixing this, I guess. And we already have quite a lot of mates going, but I'm going to try to mate everything to the screw, I think. That'll work for me. And yeah, actually I want to float that then, because I want Z0 to be parallel with that. And because I didn't mate that to the shaft of the screw, it stayed over there. So we can just go like that. And looks good. Alright. Did I put an axis in this screw? I sure didn't. So actually I want that to be coincident with not Z0, with Y0, Y0, Z. I'll just mate the origins or the coordinate systems. There we go. That way my screw starts just where I want it to, and everything else can be easily built off of that. Beautiful. So I want to make that with, suppose x0. I guess it doesn't really matter. I guess y0 will be my bottom. Yeah, that sounds like a plan. And it's going coincident, but that could cause it to overdefine by mistake later, so I'm just going to do a parallel. And again, y with y, parallel. And once more, that's fully defined, good deal. These are not. Y with, actually I'm just going to mate it to the screw. That's preferable, actually. And this one as well. Y with the screw. It's already fully defined. Well, I was not trying to grab that one, but okay. Y with the screw. 8. Okay. And good deal. So now I've got I think I've got 1/4 inch worth of metal in between there. And we'll submit that. Okay, and are we fully defined? Underdefined with the bearings. Yes, that would be a problem. I just like to fully define stuff because, you know, maybe that thing that isn't defined is something that's going to cause a relation or something that's driven off of another part to be wrong, and yeah, it's just so much easier to fix the problem before it happens. Okay, so that looks pretty good, and I'm going to save this externally as works. Ooh, I still have something nasty in this old screw, don't I? No, that's fine. Is it in the nut? It is in the nut. So I want to remove all, and good. And then, wait, 200 millimeters isn't long anymore? Okay. Save, save. Alright, so get that out of the way. If you look in there, that looks pretty good. And yeah, I think I'm going to just try to do the exact same thing on all of them, all 6 spools. So now that I've got the assembly, I can mate, and I can mate, and then last, I want the Y from that to be mated with something up there. Doesn't really matter, just so it looks nice. Alright, and I can delete this folder too. Alright, so I can get rid of that, that, and that. Those are all just for ideas, and I don't need them anymore. And okay, wonderful. So mount that up there. So much filament to be on this thing. I mean, 5 kilograms times 6. That's a lot of filament. Right, 30 kilograms. Yeah. This plate might flex at 30 kilograms. I think it's only a 1/4 inch. I mean, it won't flex much, but yeah. Alright, so I need to just take a short break here. I'm going to be back in a couple minutes, just short break. So if anyone is actually watching or if you're coming back for this, I'll be back and I'll spin the thing around a bunch as soon as I come back. Actually, you know what? I'll minimize this and I'll close this so that when I come back, I'll just bring it back up and you'll know that I'm back. Alright, I am actually gonna have to call this quits a little bit early today. I just looked outside and there's at least a foot of snow packed up against the door. And yeah, better take care of that before the sun sets in like half an hour in the middle of the day. So I will probably be back later, but I need to take care of some things. See ya.